Hello everyone. In this video, I will discuss about the batch calculation for the preparation of the ABX3 type perovskite material. Specifically in this video, I will discuss about the batch calculation for the preparation of the NBT based perovskite materials. Hence, it is very important to understand that what method will be adopted for the preparation of the perovskite material. So in this video, I will talk about the batch calculation for the preparation of the perovskite material using solid state sintering route. The very important things that need to be noted is about the raw precursor, since there are many type of raw precursor available for the preparation of the perovskite material. However, for the preparation of the NBT based perovskite material, the raw material that is available in the powder form is sodium carbonate, bismuth oxide, and TiO2. Hence, the most important things for the calculation is the balanced chemical equation, on the basis of which we will calculate the base. So, we have to see the right side of the equation, and then we will balance the left side of the equation with the right side of the equation to achieve the required batch required for the preparation of the ABX3 perovskite material. Since we can see here that on the right side we have 0.5 concentration of sodium, 0.5 concentration of bismuth, and 1 mole percent concentration of Ti. However, in the raw material we have sodium carbonate, bismuth oxide, and TiO2. In order to make balance, we need to put here some things to make it 0.5. If we put here 0.25, so this will be equal to the 0.5, because 0.25 multiplied 2 will give us the 0.5. And here we also need to put 0.25, because 0.25 multiplied 2 will give us the 0.5. And here we see that we needs 1 Ti mole percent concentration. So in the raw precursor we also have Ti 1 mole percent. So this is the balanced chemical equation. The second thing that is very important is to note that on the right side we always obtain some carbon dioxide. So if we see the left side of the equation, here from here, like these carbons, 0.25 carbon we have on the left side as a whole. So on the right side we will put 0.25 carbon initially. Now the second thing that we need is to find out that how much oxygen we have on the left side and on the right side of the balanced chemical equation. If we multiply 3 with the 0.25, so we obtain 0.75, and hence same is the case for this one, and here we have 2 oxygen. So the total number of oxygen in mole percent is 3.5. Now we will measure the oxygen on the right side of the equation as well. So on the right side of the equation we have 2 multiply 0.25, so 0.5 concentration we have as a whole on the right side. So 0.5 0.5 oxygen is here and 3 oxygen is here. So as a whole total we have 4.5. So we need 4.5 oxygen on the left side of the equation as well. So if we measure the number of oxygen atom on the left side, so we have 3 multiply 0.25, 3 multiply 0.25 plus 2 these. So as a whole we have 3.5, and on the right side we also have 3.5. So this is the balanced chemical equation. And now on the base of this chemical equation, we will calculate the base required for 10 gram to prepare the perovskite ABX3 material. It is very important to note here that you have to make this calculation in the Excel sheet. You will write first the precursor, and in the column A, bismuth oxide, sodium carbonate, and TiO2 along with their atomic masses, which is this for the bismuth oxide, for the sodium carbonate, and for the TiO2. Now, the most important thing that is required, that we have to note that on in this equation, in this formula, we have 0.5% of bismuth. But here, this is not the bismuth, but this is the 2 time of the bismuth. So when we multiply this 0.25 with this 2, so we will get 0.5. When we multiply this 2 with the 0.25, so then we will get 0.5. In order to make it balance, in the TiO2 is 1 molar in 1 molar ratio, so it is automatically, we don't need to multiply this Ti with some mathematical number. In order to check that your calculation is right, always sum this molar ratio for the perovskite material. If you got 2 here, it means that your calculation will be right up to some extent till these calculation. Now, what we will do, we will multiply the molar ratio with the atomic mass. So, in order to multiply the molar ratio with the atomic mass for the bismuth, we get this number, and same is the case for the other as well. This is the total atomic mass for the formula. Now, in order to know that how much percent we need, weight percent we need the bismuth, how much weight percent we need the sodium, and how much weight percent we need the TiO2, we need to divide the whole formula mass with the atomic mass of the individual elements. So, here we will divide the bismuth oxide atomic mass by the whole atomic formula mass, and same is the case for the other 3 as well. In order to confirm again that your calculation is okay, you need to sum of all these weight percent. If you obtain 1, then it means that your batch calculation is okay. So these are the 2 confirmation from where you can confirm that your batch calculation is okay up to this extent. Now, in order to further move to the batch calculation, you need, for example, if I am preparing 10 gram of the batch, then what can I do? So this is the weight percent of each individual oxides. Now we need to find it for the 10 gram. So what we will do for that, we will simply multiply this weight percent with the 10, with the 10, and with the 10. The third confirmation that you can done for your calculation is always sum all these precursor. If you got 10 here, then it means your calculation is right. But the most important thing is to note that I have wrote here that this is the final product with the carbon dioxide, and this is without carbon dioxide. What does it mean? Since there is always carbon and oxygen present in our precursor form, you can also find out their molar ratio and also their weight percent as well. And then if you wish, then you can find out your batch without carbon dioxide and your batch with carbon dioxide as well. That, like what I can done here, I will show you how you can do it. For example, this is the total formula mass for the constituent, but as we know from the balance chemical equation that we have 0.25 concentration of the calcium and we have 0.5 concentration of oxygen on the right hand side. So we can also measure their atomic masses in order to know about their formula mass. So if you wish to calculate the batch without carbon dioxide, then you can simply subtract the carbon dioxide mass from the total formula mass. And this is the final batch calculation without carbon dioxide. Here what I can done, in simple word, I can divide the atomic mass of the bismuth oxide with the total formula mass but without carbon dioxide and then multiply with 10. And same is the case for this one. Okay, So in order to confirm that your batch calculation is okay, since people are using several software, in this video I will also show you that we will use software as well and confirm that our equation and our calculation is same as that of software. So this is a software for the batch calculation. Here I will write the sample name x is equal to 0, and here we will put like bismuth 0.5 and sodium 0.5 and TiO3, and here I will write the raw precursor which is available in the powder form. So we will write here Na2CO3, and here we will write Bi2O3, and here I will write TiO2. So these are the raw precursor, and the beauty of this software that it will give you the molar ratio by itself. So the molar ratio will be 0.25, 0.25 and 1, same as that we calculate from the balanced chemical equation. Now if you put and click on the output, it will give you the batch calculation in the world format file. So this is basically the batch that is calculated with the help of this software. Now we can confirm and we can compare this batch with the batch that we have already calculated with the help of the balanced chemical equation with the help of Excel sheet. So in order to confirm and in order to compare it with our calculation, I will open it both in this window, and from here you will see that the calculation of the batch is same as that we have already done with the Excel sheet. From here you can see that what they have obtained and what we have are both the same thing. Okay, so from here you can see that they measure that the bismuth oxide needed will be 5.498, and here we also measure that the bismuth that is required is 5.4987. So it is the same as that we have already calculated, and here they tell us that the sodium carbonate will be 1.2506 gram required, and we also calculated as 1.25. So it is the same as our calculation. And the TiO2 they reported, they tell us that it is required will be 3.7703, but here we measure it that it will be required is 3.769 gram. So our calculation is same as that have reported by the software.